Thank you very much, Marco. I'm Andrew Crozier. As Marco said, I'm talking today about APIs for data science. I work as an engineer for ASI Data Science, which is a small data science consultancy in London. I work on the team developing our online data science platform, which is called Sherlock-ML, which I'll mention a little bit at the end of the talk. We also, as a company, we organise a data science fellowship for ex-academics wanting to go into data science and industry. Just a bit of motivation about the talk. Why do we want to have an API? Well, maybe preaching to the choir somewhat, but for any of you who are coming from a more academic background, it's often good to have like a proper programming interface to a model so that the interaction with the model from other parts of your application code or for other users who want to interact with your code is more consistent, and that developers don't need to know the internals about how, for example, a model that you've developed works. In particular, in this talk, I'm focusing on web APIs. The main reasons for that are maybe obvious to you, but may not be. For one, it's language independent. You don't have to have particular bindings into a library in order to hit a web API. It has a nice, effective decoupling application and model. Anyone who's familiar with microservice frameworks understands the value of this. And it's also easy to share with other people online. So once it's hosted on the server, then anyone who you want to have access to can potentially be given to your web API. In this talk, I'm going to go over some basic examples and code snippets of how to use Flask to develop a API into your data science model. To cover plenty of ground and to give plenty of suggestions, I have quite a lot of code snippets, but please don't be intimidated. I hope that the examples that I give you today will give you a good idea of directions that you can go and work on yourself and use more usefully in production based on some further work. I also have put all the code snippets in this talk into an example project, which is on GitHub, which I'll provide a link to at the end. So just something very quickly summarizing about HTTP. You may not be aware, or you probably are aware if you're at a Python conference, that you already make many web requests every day when interacting with the internet and a web browser. And the general framework is that if you hit a particular link in your web browser, for example, like google.com/page, then your web browser sends an HTTP request to the server at google.com, and you ask for it to get this /page, and the web server sends a message back to your browser, the response, which says okay, which is encoded by this 200 response code, and some HTML, which the web browser is then able to serve. You can potentially get different response codes. So the most famous one is 404, that the web server can respond back with to say that actually that page doesn't exist. But you can also have these different HTTP verbs. So before I had this GET request, you can also post, which is usually used to create content on a server. I'm just introducing these different concepts, so whenever I mention them later on, hopefully they're not a big surprise to anyone. So we basically want to take this same model and change it very slightly, but instead of a web browser, we have like a client, some kind of application which wants to get something out of the web API. And on the server side, we are hosting our data science model, which is able to respond to web requests with some kind of structured information. For example, if you have some classifier, you give it some inputs, like a data point, and it gives you back the predicted class according to the model. So in this talk, I'll be using Flask. There are a number of web frameworks for Python. I think Flask is a good one for making lightweight APIs. It's quite mature, and it also involves writing quite little code compared to a more full-featured framework like Django. So this is a basic Flask application, which just a very simple hello world example. You import the Flask class, and then you instantiate an instance of that class. Here I've made this little app, and then the app.root decorator then allows you to register particular functions as HTTP endpoints. So here I've got this app.root on /, so that means if someone requests /, then this function determines what content they get back. And in this very simple example, I'm just returning hello world. So once I've added all of this, including the app.run at the bottom to actually serve content on a local development server, then I can run it with this Python app.py, and then I can make requests against it. For example, in the command line, I can use curl just against the default port, which is 5000 on localhost. And that, you can see in the example I've done shown here, just prints the body that was returned, hello world. You can also use a library like requests from an external application to make requests against the API. And here you can see you get this 200 response. If anyone has any trouble reading anything on these slides, by the way, I posted a PDF version of the slides in the general Slack channel, so you can follow through. If you're more comfortable using a GUI to test out your API instead of using either a command line tool or using other Python scripts, there's a very nice tool called Postman, which is allows you to to send requests against your APIs that are running especially during the development phase, and it nicely displays the inputs and outputs, and it's a very nice tool. So I'd recommend looking at that if you like a GUI tool. Slightly more complicated examples. We already had this hello world case that if we do this, if you see in the top right there, this getting the root endpoint returns back the hello world string, although without a comma. You can register other endpoints using the decorator, just this little string field in the app.root decorator is how you register different functions on different endpoints. And similarly, you can also use these endpoints to define parameters in the URL. So the third example on this screen, you can see I've put the name field in angle brackets. That then gets passed as the name argument to the function, and I can use that function inside to determine what the response looks like. So in this case, if I call get hi Andrew, then the Andrew gets bound to name. I interpolate that into the string and return it to the client. These kinds of raw strings are very simple, but if you want to be able to parse more complicated output in a client application, then you want to be able to return more structured information. And the de facto standard for this is to use JSON, which is JavaScript object notation. And while we're not using any JavaScript in these examples, there are libraries for basically practically every language for serializing and deserializing JSON, and so it's a really practical choice for a web API that people can use from any other language. So Flask comes with this JSONify function, which helps you return a JSON encoded HTTP response. And so here I've made a little Python dictionary with the information I want to encode. I call JSONify and return that response, and then everything's kind of taken care of, and I can use request.get again in order to hit that API and get back some encoded information. During this talk, I'll have a bunch of kind of fairly small tips. One of which is to register different error handlers with Flask. By default, Flask, whenever there's some kind of error that occurs in the server, for example, if you try to request an endpoint that isn't found in this 404 case that I described earlier, Flask by default will return some JSON, which makes sense when you look at it from a browser. Let me correct myself. It returns some HTML, which makes sense when you're looking at it from a browser, because then you'll get a suitable error message that gets displayed to someone who's looking at the website. But if you're calling it from an API, from a client application, and you want to deserialize this, and the client application is trying to interpret this as JSON, then it's going to not work because it's not valid JSON. And so I'd suggest using the capability to register error handlers with Flask in order to return JSON instead. So in order to do this, I implement this JSON error handler function, which takes an exception and uses JSONify to construct a HTTP response, set an appropriate status code, and then return that. And then I can import these default exceptions from Vectoid, which is used internally by Flask. And for all of the HTTP error codes that it has, I can register this function as the error handler. And once I've done this, then the same 404 not found case that I had before now returns this JSON encoded information, which can be used by the client. For example, you can take the message string out and display that in a little pop-up or whatever. say it's like a web application. And yeah, so this now works for all of the default error cases. So for example, if I try to post at this foo endpoint, which doesn't support post, then I'll get an appropriate message as well. And this message field, by the way, was like something determined by Flask in the first case. I've taken that message string out of the exception that I'm handling. I want to go on to an example where I actually use a Flask endpoint to serve a data science model. For this, I've got this application where I've used scikit-learn just to make a classification sample training set, which is just generates this 2 clouds of points at the bottom here. You can't see so clearly, but there's some blue points and some orange points, which represent 2 classes. And I can write some code using the logistic regression classifier from scikit-learn, fit to these data sets, and at the bottom here, I've plotted out the kind of decision boundary of the 2 classes when using this model to perform a prediction. So the general input here is, excuse me, when we want to make a prediction, we have this trained model, and we need to get the 2 features and put it in a NumPy array and pass it to the predict method of the model from scikit-learn. And I can also call this predict probability function in order to get the probabilities of the of a particular data point lying in the 2 different classes. Hopefully this is fairly familiar to you if you're a data scientist, but we want to make this into an endpoint that can be served so the client applications can interact with it. And so I've used the app.root to decorate this function predict, which takes feature A and feature B as inputs, puts them into a NumPy array, as I described before, calls predict probability, gets all the outputs and put them in a little Python dictionary, which I then pass to JSONify and return in order to serve back the predicted class and the probabilities of the data point lying in those 2 classes in a JSON encoded way. And I hope it's clear then that the placeholders, the angle brackets in the get endpoint, get passed through to predict. And aside from the app.run and originally creating the app class, this is all you need in order to wrap this model in a HTTP endpoint. Yeah, so here, this is how you call it again. You make this get endpoint, predict /feature A /feature B, the values, and then the model prediction gets returned in this JSON encoded body. Since we have created the error handler, if we do something that causes a Python exception, it'll raise this internal server error. So, for example, if we give this invalid instead of an actual string value that can be converted into a float, then the line here, or the set of lines where I call NumPy array with dtype equals float, which implicitly will try to convert all of the strings that were passed into float values, that will raise, value error, and that will get bubbled up. But this is kind of not a very nice response to get just to say internal server error. Ideally, you'd like to return some information to a calling application about what actually went wrong. And the usual way to encode this would be to return a bad request, that one of the inputs was not valid. And so what I would suggest doing is that you catch the value error that happens if you try to pass in the string invalid into the NumPy array constructor. And then you can call this abort function, which comes from the Flask module, with a particular error, like HTTP error code, or particular HTTP status code. And that will basically break out of that predict function at that point and return the appropriate error response to the client using the error handler function that we registered earlier on. And so here I've given it this string, inputs and valid floats. And so then using the JSON error handler that we encoded, then in this invalid case, then we get the a more appropriate response value that can actually tell the client something useful about what went wrong. Another thing that you may find yourself interacting with a lot working on data science projects is databases. Taking the case again from before where we were training this logistic regression classifier, but instead I'm now reading the training data, not using the scikit-learn, but reading it from, not using the make classification sample training data using scikit-learn, but instead reading it out of a database, which may be useful, for example, if you want to not have a kind of toy data set that you're predicting, which is not that useful by itself. So here, hopefully this is, I'm not, for those who aren't familiar with SQL Alchemy, you need to like create an engine for the database using the URL. So here we're connecting to a Postgres database on localhost. Then I've got a query, which is just getting the entire data table, and I'm using pandas to read that directly into a pandas data frame. This is a fairly common pattern in data science for reading values out of data values out of SQL databases. And then, as before, I'm converting this pandas data frame into NumPy arrays and passing it into the logistic regression fit method. Excuse me. To use databases in the context of a HTTP server like Flask, or HTTP framework like Flask, you need to be able to. There are a number of kind of subtle issues around maintaining a connection pool to connect to the database, and by retaining session state across the lifetime of an HTTP request being handled by the framework, and this can involve a reasonable amount of configuration. In order to not have to do this yourself every time, I would recommend using Flask-SQLAlchemy, which is like an extension module for Flask. And for this, once you've installed this Flask-SQLAlchemy, then you can import the SQLAlchemy class from it. And using this code snippet, this basically does everything that you need to do the proper configuration to use SQLAlchemy within the context of a Flask request. And then you can use the engine attribute of this DB object in order to, as the connection object, and run further queries against it. Another thing that was, I think, touched on someone else earlier today is that SQL injection is a potential catastrophic kind of failure case for your application if you basically execute SQL code that is generated from unvalidated user input. And so, for example, if we are wanting to get a row out of a table in response to some that corresponds to some value that was supplied as part of the request, then someone with the right input could basically cause you to drop all the values from your table or crash your application or something else bad. And so the easiest way to avoid this is to use SQLAlchemy's query interpolation engine. And all you have to do is, in this first case where I'm using f-string interpolation to insert user input into a query, I can just use this colon and then some name, which I then provide as keyword arguments, the actual values that I want to interpolate there, and SQLAlchemy will do all the necessary protection to make sure that the SQL injection attack is not possible. One other task, another recipe is around the ability to execute slower running tasks. So a typical HTTP server model just needs to render some HTML file, and that takes maybe a fraction of a second, and then return it straight away. And so it's kind of reasonably okay in that context for the web server to basically be blocked for a fraction of a second before returning. However, the data science model may take some number of seconds or minutes to train or fit or whatever action you want to happen in response to the HTTP request, and that, in the case of Flask, will cause that whole Flask process to be blocked for the duration of that request. Also, as the lifetime of an HTTP request gets longer, the chances of that failing due to some network issue or otherwise increases quite a lot. And so the general rule of thumb is that if something's taking more than a second to respond, then you want to find some kind of asynchronous way to do that task. The way I would recommend doing this, a relatively easy way to get started, is to use PyRQ. You may have heard of Celery, but which requires more configuration, or I found it to require a bit more effort to get up and running, and is kind of it's a fantastic tool, but it's optimized for the case where you're wanting to handle very high volume of relatively small requests. The PyRQ does not handle this very high volume case explicitly, but in the case of data science models, you typically have fewer requests which take longer time. And so what you can do is, if you put your prediction logic inside a function in some classifier.py here, for example, I can make a queue using the Python RQ object. And then by calling q.enqueue with this function and some arguments, I can basically submit that task into a queue, which will then get executed by a separate process. So if in the same module as my Flask application, I have an RQ worker that will run separately from the Python application, from the Flask application rather, then that will churn away at those tasks and wait for more tasks to get executed into the queue. Being able to submit tasks is great, but you also want to be able to get them out. So I'll run through this fairly quickly, but there will be code examples I'll give a link to at the end. What I would suggest is that you store the result into a database whenever you've finished the execution, and then using a kind of like post and like get model, where the post request returns an ID that can be later redeemed against the other endpoint to get the result. This is a good model for being able to submit tasks, and then the client coming along later to check whether the task is actually completed or not. I'm just going to skip through here because I'm short on time, but yeah, here roughly I have made this post request against the API. I get this ID back in the JSON response, and then I can get against the predict/ID. Initially I get 404 because it's not ready yet, but then later I get 200 with the actual response, or the actual predicted class, I should say. Short on time, so I'll just say use API keys if you want to have restricted access. This is usually transmitted using HTTP headers. Here, these examples can show you how to do this, but generally I've just made a table API keys in the database that I'm able to check to see if a particular API key is valid or not, and then returning 401 response to indicate that the user was unauthorized in the case that there was no API key provided or that the API key that was submitted was not valid. And you can make a request in this case by just use the Python request module on the client side using this headers argument. You pass a dictionary of headers and that gets added to the request. You can use this before request decorator from the Flask application object. Is a very nice way of making your API key logic get applied to all of your methods automatically, so you don't have to remember to add it to each one, which I think is good practice. Finally, gunicorn is a good way to deploy your Flask application. Flask documentation specifically recommends that you do not use the built-in HTTP server for production applications because it's slower and only can serve one request at a time. General rule of thumb is that you use 2 to 4 workers, gunicorn workers per core that you have available on the server box that you're running it on. But if you don't want to take care of these things yourself, there are plenty of online platforms that allow you to serve Flask applications or other common web frameworks with not having to actually manage the service yourself. Heroku is the most famous, but you can also use more general cloud application providers like GCP or AWS. Finally, we have this tool, SQLAlchemy, which I mentioned, which is an online data science development environment. We provide, it has a bunch of advantages which I don't have time really to go over now, but in the context of this talk, we have APIs feature where, you can't really see very clearly here, but you basically just tell it the module and the name of the object that you want to run, and it will serve it behind the scenes with encryption and authentication. Yeah, and then you just, you definitely can't see that. But there should be an API key there that you can just copy paste, and we take care of all of this. So yeah, in summary, I think Flask is a fantastic tool for being able to quickly set up APIs, serving data science models. Please take a look at SQLAlchemy if you're interested in this kind of deployment and also collaborative data science work. And this GitHub link, Across Data Science APIs, has a application that includes all of the recommendations and code snippets that I had during this talk, and so you can see how it all works together. There's instructions there for running it and running the worker and so on. And so hopefully that'll be a useful resource for you to get started building an API from your data science models. Thank you very much.
Thank you, Andrew. A lot of sensible, useful tips. We don't have time for questions. please thank Andy again. Will you be around for the rest of the day?
Yes, well, we're leaving this afternoon, but if you want to grab me after this, if you have any more questions, I'll stick around.
Thank you.